Thanks a lot for coming to my session. I know it's late, it's 5 p.m. Thanks a lot. During lunch I heard some attendees mentioned they want to leave for pool party. You actually didn't, so thanks, really nice to have you here in the talk. I'll be talking about fixing broken windows. So we had a broken window inside our application and we solved it, and by solving this broken window we actually reduced the build time by 50%. So how the whole thing started. So this is a photo I took 3 years ago, pre-COVID, when I was coming to the office for the company I was working back then in Berlin. So I was working for the one and only major real estate platform in Germany. So we were a platform for listing real estate, so seekers could search for real estate in Germany and owners could place their real estate in Germany. And at some point in time in the morning I saw the window were broken of the headquarter in Berlin. It wasn't just this window, so next to it was like a color bomb. So there was really serious damage taken to the office. So I'm not sure how it's in your city, but the real estate market in Berlin is quite hot. So as a platform we took a neutral stand, but still there are parties that I think we do evil stuff on our platform, so it may be the reason they made the damage to our office. So, and it all started literally with the first person throwing the first stone to the office, and then others joined them, followed, and also took damage to our office. I no longer work for this company, not because of this, but there are other reasons, but also no serious injury happening. It was maybe at the night, it was just damage to the property back then. So this brings me to the broken window theory. So there's no relationship to the operating system. It's coming from the criminology theory. And in short, it states if you live in an area where there is litter on the ground, there are broken cars, or the parks are not cleaned, it's more likely that further damage or further litter will happen to these areas. So it really depends on the area where you live. If this is a super nice area, nothing is broken, the cars looks clean, I guess nobody will throw the first stone and damage the cars. But if you live in an area where it's the other way around, it's more likely that further damage will be taken because people see someone else did it already, why shouldn't I do it also? And this, it doesn't have to always be a window that gets broken. So imagine now after this long conference or after a long day of work, coming to your kitchen, you finish dinner, have your dishes in hands, you see this. How likely are you to clean your dish, make it look nice? I guess none of us are really looking into it. We will place our dish next to it and do it on the weekend, eventually. On the other side, imagine after a stressful working day, coming to this kitchen. So everything looking nice, no dishes are there, everything is cleaned up. I guess also with the Boy Scout rule, we would leave the campground or here the kitchen as we found it. So it always depends on the context, and it doesn't always have to be a window. It can be also our car, our basement. Really how things are there really have an impact on how we leave them and how we work with it. It does not always have to be a window. So this screenshot here is taken from the project I was working on back then at the real estate platform. It was an abstract integration test. So all of our integration tests were inheriting this abstract integration test. We wanted to share some infrastructure setup. Some of you might already see where the broken windows is in this small code area. This is this annotation here. So at Dirty's context made a lot of trouble for us. So back then some developer, I don't know who it was, the project was, like it always is, handed over from team to team. So you don't know who put this in. But this resulted in a lot of trouble, the trouble mainly being increasing build times. So before fixing the window, it was a mid-sized project, so our entire build and test, so running Maven Verify, took almost 27 minutes. I guess for a mid-sized project, that's quite a lot. And after fixing this broken window, so removing the annotation, we almost reduced it by more than 50%. So it was really a big improvement. Feedback cycles were getting faster, and this journey, how we or how the team removed the broken windows, this is the entire theme of the talk. So for the agenda, the introduction is now completed. What follows is a short about me. Then we will do a theory part. I will explain you the Spring Test context caching and this annotation you just saw. Part 4 is practice. So I've collected some, or my best practice and pitfalls, if you have a similar broken window, how you can fix it for your project. And in the end, conclusion and Q&A. Some goals for this talk. One goal is for you to emphasize the importance of well-written tests. If you don't know it already, you should learn more about the Spring Test context caching functionality and feature, which I think is quite nice. Then also, in analogy to the broken windows, understand how such a small impact, one annotation at a central place, can have such a big impact on the overall project health on the long run. And then, yeah, for sure, don't be the first person that breaks the window in your team. Some words about myself. So I'm a freelance IT consultant from a small town near Nuremberg. Not sure if any Adidas employee is in the session, but he or she should know the city. I'm now living and working in Berlin. I really enjoy writing blog posts, technical content, creating YouTube, especially on rainy days in cozy cafes. So I arrived in Barcelona on Tuesday. I could make this happen in Barcelona because it was raining quite hell. I've been blogging and creating content for almost 5 years now, since 2 years really with a focus on the testing part and specifically Spring Boot. I've co-authored a book about how to bring your Spring Boot application in production together with Björn and Tom. They are, I guess, both in the audience, and Tom also did a talk yesterday. There are some links, as I will share the slide afterwards, for you to check out. So let's head over to the theory part, and let's start with the Spring TestContext framework context caching functionality. I guess that's how it's called in the documentation. So for you that don't know what this feature is, what it brings to your test suite, and how it can help you improve your execution speed for your tests, this feature is part of Spring Test. So if you're developing a Spring Boot application and creating it at start.spring.io, it will be already part of your project because it's part of Spring Boot Starter Test, the Swiss Army knife of testing. So its batteries included. You already have it. You may not know that you can make use of this functionality and feature. What it does in short, when you write integration tests, so for the simplicity and for this talk, let's say a unit test is just JUnit and Mockito, and everything else I call integration tests. So whenever you interfere somehow with an application context for your test, I call it integration test for this talk. And whenever you start an application context, this takes quite some time. So for the Hello World conference applications, it's usually a second, but mid-size to large projects, at least what I've seen, it really goes into 20 to 30 seconds it takes for a fresh application context to start. So there's a lot of things happening on application start. The thread pool needs to be initialized. We're making calls to the identity server. So all of this happens during the start of the context. And it would be nice if Spring can reuse it. So why always create a new context if you already started a context that you could reuse for your next test? And that's exactly what Spring Test is doing for you. So whenever you start an application context and run your integration test, it will put it into an internal cache and then reuse it later on if there is another integration test that fits the context configuration setup. If there's a cache miss, we will take a look at how the cache looks like. Spring will start a new application context for you, resulting in increasing build times because the context needs to start. And whenever you can reuse an application context, this will really speed up the time it takes to run your integration test, because the context is already running. We just have to execute our tests, no initial delay. Everything runs fast. So now the interesting thing, how Spring Test creates this cache, how it knows what an application context, how it is configured, and how to know if it can reuse an application context. So what we see here is really the context cache. That's a screenshot of the Spring Test source code. It's a map. The key is a merge context configuration class. We will see in a second what goes into this class and how it is created. And the value is an application context. So it's an internal cache storing all the already started application contexts for testing purposes. It uses an LRU cache strategy, meaning if we start more than 33 contexts, so the initial capacity is 32, so the cache size is 32. If it goes above, it will remove and close a context that was least recently used. But with Spring Boot, you can also tweak this context cache size, so you can increase, decrease. That's as mostly everything configurable. And now the interesting thing is, how does Spring internally know if it can reuse an application context? So how is this uniqueness of the application context identified? And this is identified by many parameters that you put on your test, or how you structure the setup of your integration test. One information that goes into the creation of this merged context configuration class is the active profiles. So depending on which profile you activate for your integration end-to-end test, however you call it, you may load different property files, different beans may be loaded during runtime. So this is one of the key factors that Spring uses to identify, can I reuse the context? So if I have two tests that share the same application profile, the likelihood is high that we can reuse it. But that's just one of the factors that goes into the creation of this cache key. Another one is context initializer classes. So if you use the add context configuration class and do there some different setup, this also goes into the creation of the key. Test property sources. So if you have an integration test, if you differ loading different files per test, that's also important, because in one property file you might enable a feature, in the other you don't. So to reuse an application context, Spring really has to make sure that the context setup and the configuration is the exact same thing. Because an example, last thing here is context customizers. mockbean or spybean, for example, is such also is an indicator for Spring to know if I can reuse the context, because if you have two application contexts, one is mocking a bean and the other is not mocking the bean, an integration test can't be, you can't share it, because the one is mocked, the other one is the real one. So this is one of the parameters, and Spring merges all of this. These are also only 5. There are way more. You will find them in the documentation. And based on these criteria, so all of this then goes into the creation of the merged context configuration class, and this becomes the cache key, which identifies when a new test runs. Build this class and then check the cache. If there's a hit, extract the application context, run the test. We are fine, it's fast. If there's a cache miss, we have to restart a new application context and also put it into the cache, so the next test can reuse it. One simple example here, we have a web MVC test. So this is a sliced application test which just focus on testing the MVC layer of our application, the controller in this example. And on the left side, we have an order controller test, and we pass the class to the annotation. So what you have to know, if you pass the class of a controller, Spring will just populate this controller and all the other MVC parts. If you don't pass the controller, it will create a sliced context with all the controllers. So we have two classes here. The left one initializes the order controller, the right one the customer controller, and now the question is, if I run them in sequence, so also important, we are not talking about parallelizing integration tests, we are in sequence. Parallelizing the integration test is a complete different topic and sometimes quite hard to achieve. But if we run them in sequence, the question is, can Spring reuse the context? Here the answer is no, because we have two different controllers. If Spring would reuse the context for both tests, the second test would fail with a 404 because the controller is not part of the application context and the dispatcher servlet won't find a handler, and that's why for the second test we get a new context. With these sliced application contexts, the impact is quite small, so starting a new sliced one adds up some time, but not that much as the problem we had. So on the other side, if we would have used just at WebMVC test, telling Spring, start everything from the web slice, all controllers, put them in. In this case, we can actually reuse the context, making sure that we don't use any mock bean further down or override any other stuff. But in this example, we could reuse the context, saving some time because we will already use the started context. Then, based on this background knowledge on how the application context cache is built, there are some red flags or some parts that if you make heavy use of them inside your integration test, and if you really end up with a fruit salad of different context configuration setups, it will be really hard for Spring to actually reuse the context. And here I've put some red flags. So one of the red flag meaning if you make heavy use of this annotation and also switch it between tests, reusability is not given. So here, the active profiles, if you switch the profile activation between tests, you have 10 test profiles, Spring will have a hard time reusing your application context. Then if you import various different test configurations for all of your tests, it will be also quite hard to reuse it. If you customize the context start differently between all your integration tests, Spring will also have a hard time reusing the context. If you override, for example, feature toggling properties inline, if you do this a lot, you have a lot of unique snowflakes when it comes to the context configuration setup, and hence Spring will keep starting new application contexts for you and increasing the overall build time. Mockbean is also, as mentioned, one of these red flags. Red flags here, really, it's not meant, don't use it, but be aware if you switch it and switch the setup, you have some downside when it comes to reusability. Some indicators for you. So if this feature is completely new to you and you're wondering how does it look for your project, what you can do if you come back to your project on Monday, run your test and see, for example, in IntelliJ prints the duration. And if you see the first test took 200 milliseconds and then the next test took just 4 milliseconds, you know, okay, probably Spring reused the application context in this particular example. Or another good way as an indicator, if you check the logs of your tests and search for the Spring Boot banner, which you should enable, whenever you see this banner, you are starting a new context. So the more often you see this banner, the more context you have in your integration test suite and the slower your build time is. Another more technical way to see some internals, also a great idea for you to just enable this logger, put it on trace, and then the Spring test outputs some log statistics after each test and gives some internal knowledge about how big is the cache. So you will get to know at the end of your test suite, so enable this logger, run all your tests, and then check the last log output. And then you will see how many hits we have. Here we have 11 hits, how many misses we have, 1. And this should give you a first indicator to see how good your project is in regards to reusing the application context. Yes, so this was the theory. So I guess it's a quite nice feature many developers are not aware of, and they're throwing annotations at their tests hoping to make it work, but don't have this theoretical input in the back of their heads. So coming back to our broken windows. So now what does this annotation do, this dirty context? We had it on top of the abstract integration test class. Someone added it back then. I can imagine how it happened. There was project stress, a feature had to be delivered, and they were struggling, for example, with the test setup, and then found an issue, some assertion went wrong when running them together, searching on Stack Overflow for a result, scrolling down, and then someone mentioned, just put this annotation on top of your test and it will work. It worked, but he left us with a broken window, and this really made it hard for us to have fast feedback cycles, because what this annotation does, so this is from the Java doc of Spring, it will mark the context either before or after the test, so you can configure this also before or after the method, as dirty, and then won't consider it for the internal context cache. So it will run the test fine, start one, but then immediately close the application test context and remove it. So there's no chance of reusability, because because the context is dirty. There are valid use cases to use this annotation. If you, for example, modify global state, which you shouldn't in your integration test, then you can use this annotation to tell Spring, hey, I did dirty things, remove the context, I don't want to use it further. Yeah, but if you have this at such a central place, we had the issue that we were lazy developers. Every new integration test was extending this abstract integration test class, and every integration test then really started its own context, because due to the annotation, it was marked dirty, not considered for the context cache. You get a new one. So, and this was piling up, because each new integration test was adding roughly 20 to 30 seconds to the entire build time, and this was a mess. There was also no effort made on fixing it. I mean, we were aware that this is a technical debt for sure, but yeah, we had several attempts. So the classic, we have 4 hours left between the current sprint and the next sprint. Let's fix some technical debt. So many of us tried to just remove the annotation, but a lot of tests then failed due to various reasons, which we will discuss in a second. Yeah, but we never really focused on removing it, and just minor attempts really didn't help to remove this. And overall, I mean, increasing build times really decreased the motivation and the likelihood for us to add meaningful and important new integration tests, because we already knew, add a new one and the problem gets worse. Add a new one and we have further, and the build time gets even longer. So yeah, no motivation to fix it, no motivation to add new integration tests. That wasn't quite nice. So in the end, also our motivation decreased a little bit, because if you don't have this fast feedback cycles and can't publish your change to production quite easily, it doesn't make fun to develop features. So at one point in time, we said, let's fix it. So we had a strategy. I mean, it was part of our backlog, marked as technical debt for ages. Nobody took care of it, but at some point in time, we thought, let's gather, let's plan this accordingly, and this was our strategy. So really, together with the product owner and all the stakeholders, we said, we have to fix this. This is hurting us more and more on the long run. So we planned it accordingly, we put it into the sprint, really dedicated some time for it, so there is no rush and nobody trying to do it in the afternoon, in the evening, on a weekend project. It was really planned properly. What we also did, we grouped, so those lucky developers that tried to already remove it, they all found different rabbit holes which they ran into. So we collected all those issues and had a rough roadmap of parts we knew will break when we remove this annotation. So this really helped us for first plan on what to fix. Then the action part, getting rid of the annotation, as simple as it sounds, wasn't that simple, but this was the third step. And then as the last step, we wanted to share the knowledge So internally and also now on this conference, if you are aware of the context cache and all those things that go into it, I guess you have a different style of writing your tests. You are aware of it and really share the knowledge within the team, the company, and in the community. Okay, so now the practice part. I collected the top 5 pitfalls, recipes, however you want to call them, that we had to overcome when removing the annotation. Because as soon as we removed the annotation, our context remained in the context cache. So they weren't closed and shut down, they remained in this cache, and we were piling up. And at some point in time, we were identifying that we have flaky tests, especially when it comes to our message listeners. So we had a lot of SQS listeners that were listening to an SQS queue. We were using local stack with test containers to provide a mock AWS cloud locally and then populating messages, doing stuff. But the thing is, with this @dirtiest_context annotation, in the past, every test, there was just one context. Afterwards, it was removed. So now we had multiple. And those contexts remain open. So they are sitting there next to each other. Unfortunately, we configured just one test queue. We were populating messages. All context caches that were up and running were eagerly consuming from this queue. We had some tests where we were waiting for the message consumption to happen, but it happened in a different context. So this was a pity for us. We were using here a sample code. This is a listener, a SQS listener, not doing much business logic, consuming just the payload. And what we did to solve it, I mean, there's a big issue having just one queue for the entire test, and if you shut down the context, everything will work, everything is fine, because there's only one listener running at a time. When removing the annotation, we had multiple listeners running at the same time and couldn't write the assertions as predictable as we wanted. So what we used is kind of a recipe. We used an application context initializer, so you can implement this interface and then you can develop any custom code that gets executed upon application context start. So we didn't put this into our production code, but rather into our test code and then configured it for our application context. And what it does, it creates a queue name, uses some randomness. It doesn't matter. It just has to fit the naming patterns of the queuing system you're using. So this pattern is not only for SQS. This is also for any other messaging queue, ActiveMQ you're using. And what we then did, upon application context start, so shortly before executing the actual integration test, we were populating the infrastructure within here. So we were using local stack and then internally creating this SQS queue, and we were binding a random queue name to each application context. So each context had then their own infrastructure. The cool thing is we just needed one local stack instance because the test container could be shared. We were then just splitting up the queues, and every application context got their own queue. And the cool thing is within this application context initializer, you can then override any property. So we now need to make our application aware of this random queue. We can't hard-code it. It depends on each application context, and then can dynamically override here the invoice queue name, and then the test runs, has its own queue. We can populate it, and everything worked on that end. And to activate it, you can use this annotation here, and then can pass many initializers to your integration test setup, and then this code gets executed on each context start. The next pitfall, data overflow. Having just one context, and back then we were also creating a new database for each context, which was bad. We encountered also quite early assertion errors when it comes to asserting rows in the database. So sometimes flakiness, then when we changed the order of running the tests, other tests failed, so there was a lot of back and forth when it comes to data. And with data overflow, I relate to any relational database, NoSQL system, S3 buckets, or any persistent storage. You also provision for your tests. when you find issues there, things to consider. So in general, you should avoid any test data left over between the tests. So each test should start with a clean state. And as we had this at dirtiest context annotation, nobody cared about cleaning up because the context was removed anyways. We got a new database, so why clean up? But this hit us really hard when we removed the annotation and we saw data is being left over. Some tests do clean up, the other don't. Some pre-prepare for the next test, and we had some implicit ordering on the integration test, which was a hell. But there in general, as a hint, avoid any data leftovers between the integration tests. Each integration test should have the responsibility to populate and clean up data it needs for running. Some important concepts to understand. I won't go into detail, but if you're working with relational database, take some time to understand the entity manager flushing. Second versus first level cache, so there's a lot of confusion then when is my data committed, is this persistent? So there are great articles in the internet that help you understand what these concepts are about and how they work in tests, because the next example is transaction handling. This also differs for the test. If you use @transactional on a test, Spring will roll it back, but we had some tests that were committing the data, some were not. So this is really something to align in your team, find your strategy, and be aware of the issue. Yeah, as another hint or recommendation, use test containers for everything. Provision the database, provision the S3 bucket, or any other infrastructure resource you have. When it comes to schema migration, you can use tools like Flyway or Liquibase, and you can even go a step further and share one database for your entire integration test setup. You may have multiple application contexts, but if they don't run in parallel, they can connect to the same database. If you're using Flyway or Liquibase, the first application context to start will prepare the schema. The rest can just work with it. So also there is some timing improvement. Yeah, and if you have other persistent storages, NoSQL databases, there will be a solution for your infrastructure. The next pitfall were remote connections. So our mid-sized Spring Boot application was talking to a lot of systems via HTTP. And for example, we had a Salesforce client that was initialized upon application start, or we were in resource server, we were communicating with the identity provider upon application start. Then we were fetching data synchronously, so I guess every application has some HTTP communication. And when it comes to testing, you have to be really sure what you're doing. So what we aimed for, and we also identified many places where we're reaching out to the real services during our tests. It just worked because the remote system were up and running. But what we aim for, or what I also advise always, is to aim for airplane mode. So take your application, go on plane, unplug the internet connection, run your integration test. If it succeeds, great, you passed. If it fails, probably you are still doing some external calls to systems, which you should avoid. And to avoid any real HTTP communication, there are great tools out there, WireMock, for example, which you can use to stop any communication. Should make it reproducible and predictable, because you don't want to run into rate limiting issues by going out to the real remote system for your integration test. One strategy or one recipe we then found, or which worked quite good for us, is again the application context initializer. And one additional note here, you can also use the @order annotation to, if you have multiple context initializer, you can order them. So if there is an ordering dependency, you can really say, Spring, please execute this initializer first and then the other one. So what we did, we started WireMock upon application context start. So WireMock is a testing tool that you can use to stop HTTP communication. It starts a local jetty, and then you stop HTTP communication, and then your system under test talks to WireMock and not Salesforce or SAP. And what we did, we started it. WireMock starts quite fast, so the additional overhead of starting a new jetty server for each application context wasn't that much. So we measured and said, go for this. What we also did then, as we had some HTTP calls that were going on up on application start. So when Spring initializes the context, we already were reaching out to various providers, for example, the identity server or Salesforce. We had to already stop and prepare via mock to respond something. And this we combined inside this application context initializer. And here, for example, the pattern is, I would say, similar to page objects for web test. We extracted all our stubs into stub classes. So for example, here is the OAuth2 step class. We will see it in a second. And then after starting wiremock, we could already prepare the OpenID configuration response. We could prepare the JWKS. So the key exchange could be already stubbed, and this was quite helpful because if you do it later, it's too late. If JUnit runs your test and you're inside your test method, the context has already started and the call has already been made. So gluing this here together was quite nice. And this is an example of such a stub class. So we outsourced the stubbing to a central place and then here stub the OpenID configuration. So you can also use, if you're using Keycloak, then use a Keycloak test containers. But this is also a valid approach to stub your HTTP calls, and it can be applied to any other system. And then the cool thing is we can not only override or configure properties, we can also, or we have access to the bean factory. We can register beans inside this application context initializer. So this is the last piece of the application context initializer. We put in the stub class, so other tests could auto-wire the stub and then stub different things. We also placed in an RSA key generator. So if we then have an integration test that goes really the full round trip, it needs a signed JWT. If we create our private and public key there on demand for testing purposes, we could eject this generator, sign the JWT, and hit the endpoint. Yeah, and then last but not least, overriding here as wiremock starts on an ephemeral port, we have to make this dynamic and pass over the port. Okay, then pitfall number 4. My most favorite one at Spring Boot test obsession, I called it. So I see this quite often on projects or on Stack Overflow, people trying to write tests for their classes. Here's a really simple order servlet. It doesn't do much. The business logic is not really necessary for the showcasing, but what it has one collaborator, a customer service, and it does some business logic. What you will then sometimes see, people use at Spring Boot test annotation to write a unit test just for this small if block here. So they want to see if here the implementation works. What they do, they use at Spring Boot test, they get an entire context, everything gets started. They mock their collaborator with mock bean, so they replace what they want to mock, auto-wire their class on their test, which is the order service, and then write their tests. So, I mean, this works for small projects where the setup is not big, and it's also, I guess, if you're starting out, a valid approach. You create your first Spring Boot project, see that Spring Boot auto-generates a test for you, and this already has this annotation, and from its name, at Spring Boot test, you may apply that, use this for all of my tests, but this is really not the idea of this annotation. So there are a lot of places where you can, or where we also replaced at Spring Boot test with a basic unit test. So just focus on, or just use JUnit and Mockito. Don't start a context, don't start the database, test your business logic in isolation, and don't over-engineer stuff with this annotation, because the downside is you get a new application context. The bigger the application, the longer it takes. With JUnit and Mockito, it's quite fast. So yeah, there are really sometimes no reasons to use at Spring Boot test for unit tests, and I hope after this talk you will also remember this, because actually there are quite a lot other great annotations from Spring Boot. So Spring Boot comes with a lot of sliced application context annotations that make it simple to test different slices of your application. We already saw the @webMVC test annotation to test the web part. There is web flux test. There is recently added to Spring Cloud AWS @SQS test, where you can test your SQS listener in isolation. It will just start a slice of your application context. It will just start SQS related beans, no database, no resource server connection, no web clients are being initialized, just the part that you want to test. So really take a look at all those annotations. There are quite a lot. There's one for data Mongo test, for Cassandra. You can even write your own annotation, and then if you have a different slice, my company slice application test, prepare the context that you need, and only use @SpringBoot-test as a last resort, or where you really want to see everything being started. But most of the times you're really good to go with one of these annotations and don't need @SpringBoot-test always. Then the last pitfall, setup variety. As already mentioned, you should, or if you want to make use of this feature and reuse the context as much as possible, you should really try to make sure to not vary in your context configuration for the test. So don't have unique snowflakes, and really try to focus that you reuse the same context, at least for the bigger tests. So for @SpringBoot-test, try to reuse it, or just have a subset of different context flavors, and then all your tests will use it. Some hints here, or what we did, we had various test profiles. We had slow tests, database tests with front end, so we really cut it down to the minimal profiles we needed. And for us, it's mainly an integration test and a web test profile. If you can go even further, the better, because the more profiles you have, the more variety you have, the more context you get. Avoid unique snowflakes. Don't overuse mockbean and spybean. So as you've seen, don't use it for the unit test approach with @SpringBoot-test. Really think twice if it's really necessary, or if a different test would fit better. Manually overriding properties, also try to avoid it if it's really necessary. If you, I don't know, have a feature flag, covered application code, rather write a unit test that tests the different branches, and then have a happy path test that tests with the normal configuration, but don't mix and match it between your integration tests. And then one thing we learned the hard way, always, when you can, favor either JUnit Jupyter extensions that are already there, or write your own, over extending an abstract base class, because composition over inheritance, with those extensions you can really plug in the stuff you need. With the abstract integration test, all our integration tests inherited what we had. And if one test said, I don't need this part, yeah, you are locked. Then the results. So I already teasered them. 12 minutes, I guess, is quite a nice achievement. In the end, it was a 3-day full-time investment. So you saw the 5 pitfalls. There were more, but this were really the most central one. And once we solved them and had these recipes, it was really great. Build time got reused, and new integration tests, they only added a negligible amount of time because we could reuse the context. No additional build time needed. It was quite fast. Team was happy. In the end, the final context cache size, so our context cache for @SpringBoot-test, so for bigger application context, was in the end 3. So we still had some setup variety, so we didn't religiously optimize to just have one integration, one application context. 3 was, I don't know, our number. Before that, we had 20. So when removing @dirty's context and taking a look at the output and this trace, it was reporting that we are about to start 20 different application contexts. Yeah, we did some internal knowledge sharing. So we made everyone aware of, if you use such testing features, be aware of the downsides, and the next time try to reuse an application context that is already started. Before I jump into the conclusion, one final thing. If you're interested in testing, I've put together really a big online course on this topic, because I think there is very little content out there in the internet that talks about testing. Everybody talks about GraphQL, shiny new features, but then once you apply the stuff you learn here, you come back to your project and then raise the PR, and then yeah, your lead engineer will say, where are the tests? Rejected, right? So I took the initiative to really build here a hands-on online course. It's 120 video lessons, 10 hours of content with a, what I would say, a real-world tech stack. So Spring Boot, we have AWS, we have Postgres, we have React. So it's a small self-contained system where we do stuff and where I showcase the patterns, and Spring Context caching is also part of there. So if you're interested, and then one final advertisement slide, sorry. The book I've mentioned, Stratospheric, I guess it's also quite interesting for you if you're working with AWS and Spring Boot, which is an awesome combination. We have written an ebook, also quite big. It's available on LeanPub, so we wrote it with 3 people, and also here on the Spring I/O we met for the first time. So we were writing this book 1 year remotely, Tom sitting in Sydney, Björn and me living in Germany, but we still organized to write a 450 pages long hands-on book on how to really bring your Spring Boot application with minimal AWS knowledge to production, and then in the end have an entire CI/CD flow with GitHub Actions, use the AWS CDK for infrastructure provisioning, so no longer YAML CloudFormation files. We use Java code to express our infrastructure needs, and yeah, check it out if you're interested. And then let's come to a conclusion. So in general, think twice before implementing a workaround. You now saw this smart developer adding the annotation to our project. Yeah, it fixed his or her issue, but for us it was really a mess. And the first one that breaks the window, the second developer sees, hey, this passed the PR, our lead engineer might have approved this, my workaround is less worse, I can put it in there. But if you have a clean project, I guess your team is less likely to introduce a workaround. Treat testing code as production code. Your future self will thank you, your future coworkers will thank you. It will speed up things on the long run. Don't try to religiously minimize the context. So what you now saw, don't go to your project and then say, my goal is just one application context. Measure, adapt, and see where your sweet spot is. Try to avoid dirty context at a central place. You now saw what you shouldn't do at home. In general, show some love to your tests and Unix snowflakes. Composition over inheritance, I guess this is a great example. I mean, there's a lot of text in books that says, that preach this composition over inheritance, but here you have a real example where this hurt us. If we wouldn't have the inheritance inside our test suite, we wouldn't have the issue. And short feedback cycles are the best. So that's it for the talk. The questions will be uploaded. If you want to reach out and talk about testing, reach out via Twitter. DMs are open. You can join my blog. Also, big thanks to Sergi and Abraham and all the others making this conference happen. I learned yesterday that most of the helping hands are from university, so they are doing this on their spare time. They don't get compensated for it, so I guess that's great. It's great to be together. Enjoy the final talk. Yeah, safe travels and stay safe.